Okay, we're in section 26, which is the quadratic formula, and it's the technique of solving a quadratic equation. We've had variety of techniques, and my favorite technique is zero product rule if it works. Then we had the square root rule. Then we did completing a square, and now we got this quadratic formula, which you've already seen before. We've actually tried it on a problem, but the deal about this one over here is we need to derive it, and the way we're going to derive it is by completing a square. It's going to be more difficult, though. Some students have a tough time following this, but the bottom line is I still have the responsibility to go through that with you. All right. So we're going to be given a standard quadratic equation. That's ax squared plus bx plus c equals 0, provided a is not equal to 0. And we'll go through this over here. Again, everything's written down for it, but I'll go through it and we'll derive a formula. Then what's our intent over here? To be able to do problems using the quadratic formula. All right. So I'm going to switch to whiteboard and we're going to derive the quadratic formula now. It's going to be a short lecture. And I want to point out, even if you can't follow it, you still have to know the outcome of it. And what's the outcome going to be? Well, if you have an equation of this form over here, you'd have this solution over here. The in-between part is what students have a tough time with, though. There's no doubt about it. So let's go through that and one step at a time, so to speak. All right. So I'm going to switch over to my whiteboard now. And yes, we'll get to examples after this. Okay, we're going to derive the quadratic formula. All right. Now, again, I realize for some students to say, I don't care how you get this thing, might as well made it up as far as I'm concerned. But we need to be able to do this at some point. All right, so I'm going to claim over here, it's nice to know how these things are derived. So let me write this down for you. And what do you get over here? A x squared plus bx plus c is equal to 0. This is abstract, by the way. And what do you mean by abstract? It's something that, I don't know concretely what the A is, the B is, or the C is. The only thing I really do know is I know the A is not 0. So what I can do is divide both sides by A. And I'm going to do that now. Now, someone says, why would you do that? It's going to make it much worse for me. The reason for that is when we introduced completed squares, we needed the coefficient on the square term to be 1. And now it's going to be 1 because A divided by A is 1, provided A is not 0. Let's write this down. So now I got the coefficient of 1 in the square term. What do you get now? B over A x plus C over A equals 0. Well, that was pretty simple to do. We can definitely divide both sides by A. Now what are we going to do? Well, we're going to complete the square. And this is where it gets tough. Now, what do we do to complete square? We have to isolate the constant. How do I do that? By subtracting C over A from both sides. And let me write that down for you now. What do you get? X squared plus B over A x equals minus C over A. Now that's done. Now, so what are you going to do now? Complete the square. How do you do that? You have to take half of this guy here and square it. And I'm going to write that down now. I'll put this on the side. So if you take half of that number and squared it, you get this over here. So I took half of B over A and I'm going to square it. And what would you get? Well, this would give you B squared over 4A squared. All right, I'll write that down. So I'm going to add B squared over 4A squared to both sides. Okay, I'm going to keep going. On the left side, we have a perfect square. And what's that going to be? X plus B over 2A. If you want to verify that, you can. But if you did square that out, we're going to get x squared for the first term. Last term, you get b squared over 4a squared. The middle term, what do you get? Well, you get, let's see, 2b over 2ax, which would be b over ax. What do you get in the right side? I got a common denominator. I'll write this down for you, which should be 4a squared. What do you get in top? I'll write a little bit differently. You get b squared minus, well, I have to multiply the bottom by 4a, right? So multiply the bottom by 4a, multiply the top by 4a, you get 4ac. All right, that's not so bad. Square root rule, what do you get? X plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 4a squared. It looks like a nightmare, there's no doubt about it. Got to keep going though. So what do you get over here? X equals, I'm going to subtract b minus b. I'm sorry, I'm going to subtract b over 2a from both sides. And here comes something interesting over here. The square root of 4 is 2, but believe it or not, the square root of a squared could be either plus a or minus a, but that doesn't matter to me. All right. I'm just going to put, and the reason I could have plus or minus on there anyway. Put this a over here. And what do you have here? Root b squared minus 4ac. All right. This is tough though, isn't it? So we keep writing it. And you get x equals common number 2a minus b plus or minus b squared minus 4ac. All right, put out where I'm seeing this, right here. What does this correspond to? This equation here. We just did all this work here, but here's the deal. You don't need to do that in the exam. What you need to do, you need to take this thing here and put that there. What does that mean you have to do? You need to identify in the problems that they're written like this. And for you to do this one over here, you need to specifically state what the A is. You must specifically state what the B is. And you must specifically state what the C is. If you can do that, great, do it. Then what do? Plug it in. What's the problem with using the formula though? For a lot of students, it's a simplification. You have to simplify. And that might be difficult. All right, we'll get there though. All right, thank you for listening.